Hello everyone, we are learning now finding mean. In the previous video, we learned how to find out mean by using direct method. In this video, we will be learning to find out the mean by using assumed mean method, which is also known as deviation method or the shortcut method. Generally what we do, we apply this particular method when we are having the large values of xi, that is data. Data are very large. What we do in this method, the algorithm of that is, first of all, we will be forming the frequency table for the given problem, or the data which we have collected, we are to arrange in the tabular form. Then we are to assume any of the arbitrary number as mean. That's what we call as assumed mean. It is to be taken generally in the middle of the given data, or somewhere near the middle. Also, it can be taken anywhere or any other number than the data, but generally we take the number somewhere in the middle of the data. Because by using that, we will be getting the values of the deviations equally distributed and not very large. The next step will be find the deviations from A of that of data, that is the deviations of xi from A, and that can be written as di. Di is the notation for deviation, that is equal to xi minus A. Then we will be multiplying fi and di, the frequency to the deviations, and we will find out the sum of this product of fi and di, that is represented as sigma fi di. And also we will find out the sum of frequency sigma fi, because that is n. And then we will be finding the mean by applying the formula x bar equal to A plus sigma fi di upon sigma fi. We will take some of the examples based on this now. The first example we are going to discuss is based on unclassified or ungrouped frequency distribution. When there are no classes, no groups, and we have formed the table xi, the data are given 20, 25, 30, 35, 40, 45 and 50, and the respective frequencies are 5, 2, 3, 4, 2, 5, 4. Next step, we have to find out, or we have to assume one of the arbitrary number as the mean. As I told you that we will take somewhere in the middle or near the middle. Suppose we take it as 35. If we take it as 35, we underline this so that we remember, yes, this is 35, we have taken as the assumed mean. And we write here, let the assumed mean be A, that is equal to 35. Then we have to find out di, deviation. Deviation is xi minus A. We'll write here 20 minus 35 is minus 15. 25 minus 35 is minus 10. 30 minus 35 is minus 5. 35 minus 35 is 0. 40 minus 35 is 5. 45 minus 35 is 10. And 50 minus 35 is 15. Then now we have to multiply these frequencies and the deviations. So fi into di, 15 5 is 75. It is minus 75. 10 minus 20. Minus 5 into 3 minus 15. 0 into 4 0. 2 into 5 10. 5 into 10 50. And 4 into 15, that is 60. Now we have to find out the sum of all FIDIs. For that, to make it easy, what we do, we add all the positive numbers together. Here we find it is 10 plus 50, 60 and 60, 120. And all the negative numbers together, 75, 20, 95 and 15, this is minus 110. Now it's easy to add them. 120 minus 110, this is 10. The sum of all Fi di is 10. The sum of frequencies, that is 5 and 2, 7, 10, 14, 16, 21 and 4, 25. So we are getting here sigma Fi into di is equal to 10 and sigma Fi, that is sum of frequencies, is equal to 25, which is representing n, the number of data. And then we find mean, therefore mean is equal to x bar, and that is a plus sigma Fi di upon sigma Fi. Substituting the values, we get here 35 plus 10 upon 25. We know 10 upon 25 is 0.4, so this is 35 plus 0.4, which gives us the answer as 35.4. So this is the mean of the distribution given to us. Now we will discuss one of the example on classified or grouped frequency distribution. The next example based on the classified distribution is here. We have been given the class intervals from 0 to 8, 8 to 16 and so on up to 40. The frequencies, respective frequencies are 4, 3, 6, 5, 2. Now we know in the classified or grouped frequency distribution we have to find out xi, that is the class mark of each class, and that is given by u plus L by 2, that is upper limit plus lower limit divided by 2 for each class. And the class marks here are 0 plus 8 divided by 2, that is 4, 8 plus 16 divided by 2, that is 12, and so on. We get here 20, 28 and 36. And now we have to assume one of the number as the assumed mean a. And as I told you, we take somewhere in the middle. Suppose we take as 20. So we underline this here and we write let the assumed mean a be 20. Now we have to find out the deviations. Xi minus a is 20. So here it comes as 4 minus 20 is minus 16, 12 minus 20 minus 8, 20 minus 20 is 0, 28 minus 20 is 8, and 36 minus 20 is 16. And now we have to multiply Fi and Di. Please remember, we have to multiply Fi and Di, because many times it is seen that these two numbers are near, that is Xi and Di. By mistake we multiply these two only which are nearest. No, please remember, we have to multiply only Fi and Di. And here it is 16 into 4 minus 64, 8 into 3 minus 24, 0 into 6, 0. 8 into 5, 40, and 16 into 2, 32. Adding the positive numbers, we are getting here 40 plus 32 is 72. And adding the negative numbers here, we are getting 64 plus 24 is 88. So we have the sum of Fi di when we do, this 72 is positive minus 88, which comes as minus 16. And now we find the sum of frequency, that is 4 and 3, 7, 13, 18 and 20. So we have found the sum of frequencies as well as sum of Fi and Di. And here we write sigma Fi Di here is minus 16 and sigma Fi, that is sum of frequencies, is 20. And now we apply the formula to find out the mean. So we write therefore mean x bar is equal to a plus sigma Fi Di upon sigma Fi. Substituting the values, we get here a is 20. It is minus 16, so this will be minus 16 upon 20, which is equal to 20 minus 0.8, which gives us 19.2, which is the answer, that is the mean of this particular frequency distribution given. After learning about the mean by assumed mean or shortcut method, in the next video we will be learning to find the mean by using step deviation method. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.